Hello friends, we are bigdatahandson.com. Our website bigdatahandson.com. You can visit our website. So if you have any doubts, you can message in this number 978988844, or you can send email through support@bigdatahandson.com. Today is day 18. So we will see logistic regression. So previously taken sessions will be uploaded in our YouTube channel bigdatahandson.com. You can see all the videos here. So if you want to subscribe to our channel, you can subscribe to our channel. You will get all the updates. Okay, so now quickly we jump to our today's topic, logistic regression. So yesterday we have seen the polynomial regression. So polynomial regression fits in on a curved type of data, right? So what about logistic regression? So logistic regression actually works for classification type of data, but why it's named logistic regression, right? So we have a doubt. So I will explain to you. So what is logistic regression is, for example, uh, in logistic regression, you will have a data of classification. Classification means you will have only in the outcome will be two categories like this: 0 or 1, yes or no, true or false. So like that, if you have, that is a classification type of data. So for that, what you need to do is you need to choose a classification algorithm like logistic regression. Okay, so the data will look like this. uh, like here, for example, we have 1 or 0. Let's take classification 1, this is 1, and this is 0. Okay, let's take this is 0, 1, and 0. So we draw some points. We have, for example, for 1 we have some points, for 0 we'll have some points like this point, this point, because it is a classification, right? Only it will have the points here only in 0, or it will have some points in here in near 1. Okay, so if you saw this type of cases, if you draw a straight line through the data, what will happen is some points you can see is far away from that, so you will get more errors, right? So in that case, what we'll do is we'll create a curved line. It's called a sigmoid line, like this. So like if you create a sigmoid line, you can see here now these points are correctly predicted and these points are correctly classified, right? So so logistic regression is nothing but creating the regression line as a curved line. That's it. That's what we'll do in logistic regression. Okay, that's why the name itself is logistic regression, because the prediction will be a probability. Okay, so the probability ranges between 0 to 1. That's why it's named as regression, because it's a continuous value. It will give the probability, so that's a continuous value. Okay, so let's see the definition here. Logistic regression produces results in a binary format, which is used to predict the outcome of a categorical dependent variable. Okay, so outcome will be either discrete or categorical, such as like this. So we know that categorical type of data, right? So if you have two categories, two classes in your feature, so 0 and 1, like yes or no, and true or false, and high and low. These are some categorical data. Okay, so why not linear regression? So we have seen that why it is can't fit the regression line onto the classification type of data, so we cannot fit the line regression line. Okay, so we cannot use the linear regression to predict binary outcome because the output of linear regression ranges from infinity to infinity. Okay, so in the linear regression, actually the outcome is infinity to infinity, but here we have only two outcomes, 0 or 1. Okay, at the end of the linear regression we use logit or sigmoid function, so that I have shown to you, like initially we have a regression line, so to convert the regression line into a sigmoid line, so that's a curved line, so we use logit or sigmoid function to transform output in the range of 0 to 1. So after this operation you will get a probability ranges between 0 to 1. Okay, and then probability values less than equal to zero point 0.5 are classified as, okay, so this zero point 0.5 you can say as a uh, threshold value. So that means the greater than the greater than the threshold value that are classified as one class, and less than this value classified as another class. So that's what we use this threshold value. This threshold value usually we use zero point 0.5. You can also change the threshold value, that's your choice. Classified as class 0, and probability values greater than zero point 0.5 are classified as class 1. Okay, and then how the sigmoid function is generated using the y equal to mx plus c. This is how we derive the equation of sigmoid. So initially all these uh, algorithms which we'll see, that algorithms are actually derived from the uh, linear equation only, y equal to mx plus c. Okay, that's why it is very important algorithm, the linear regression. Okay, so we'll see that y equal to mx plus c. Here the y and x varies from infinity to infinity because it's a regression equation. So now we are converting the y into p. P means the probability. So now the probability will vary from 0 to 1, right? And replacing p with odds ratio can vary from 0 to infinity. So now we are taking p by 1 minus p equal to mx plus c. We are taking log. Okay, to remove the log we'll take e power, so both sides, and then it will come e power mx plus c here. Okay, now it is inside in the denominator we are taking into the another side. This side it's came 1 minus p, and just we are multiplying it inside 1 and p. Okay, so and then what we are doing is we are taking the common element p outside, and we have 1 plus e power mx plus c equal to e power mx plus c. And then this part we are taking into the and the uh, right RHS, so right hand side, so it is on the divide. Okay, now what will end up is 1 by 1 plus e power minus mx plus c. So if you see we have this equation, actually mx plus c, we have the regression equation mx plus c. But what it is doing is, if you take e power and minus mx plus c and dividing it by 1, then it is converting the our predicted result into ranges between 0 to 1. That's what it is doing. We divide it to 1 by, and then taking e power, so that's why it will convert to 0 to 1, the range. Okay, so the sigmoid function, if the value of our mx plus c is very small, then p approaches 0. Okay, and then if the mx plus c is very large, then p approaches 1. Okay, so this is how we converting the regression line into a sigmoid line. then we predict the classification type of data. Okay. Okay, now we'll see some practically we'll see now. So let me open the Anaconda Navigator. So today, which data I'm going to use is I'm going to use. Uh, Let me go to Kaggle website. So go to the data tab, and here in the search bar, type prostate cancer. Here, I will type prostate cancer. This is a classification data which you are going to predict whether the person has cancer or not. Predict. Actually, you can use this one. So let me launch the spider. So this data will use now. You're going to use. So this column you can see here, diagnosis result is what we are going to predict to classify. Going to classify. Okay. Okay. Now spider is opened. We'll create a new file. Okay. So now first we'll import the libraries that are pandas, matplotlib, numpy, cbond. We'll import that first. import pandas as pd and import numpy as np, and then we'll import matplotlib, and then of course we'll import seaborn library. Okay, okay, so let's run this, import the libraries. So now we are imported the libraries. So now what I'm going to do is, instead of using the data which we are taking from Kaggle, so I'm just going to take a dummy data, and then we'll explain the logistic regression, and then we'll use the library, sorry, the file data, the prostate cancer. So let me create a dummy data. If you want to create some dummy data, if you don't have, no problem. You can use the sklearn library to create some dummy data. So how can you do that is, from sklearn the data set, import the, if you want some classification type of data, you can import a function called make classification. Make class. So you can see here. So we have many functions is there. So if you want to create a regression type of data, you can use make regression, or you can, for classification, make classification. We have blobs, moons, circles, so like that you can use these functions. So I'm going to use make classification function to create some dummy classification data. So here we'll have two variables, x and y, dependent and independent variable. So we call the function make classification, and inside the make classification you need to give some parameters. uh, you can press Ctrl I to inspect. In the help it will show you. So we have one parameter is called number of samples. Number of samples, let's take 500. And for classification, for regression, all this type of data, you need to give number of features, right? Features means number of columns you want. For example, I want two columns and two classes. Two classes means, uh, for classification we will have categories, right? 0 or 1, yes or no, like that. So I will take 0 or 1. So you need to put number of classes equal to 2, and one parameter we need to give, n redundant, n redundant equal to 0 set as. Okay, so now if you run these two lines you will get the data. So actually the make classification, if you run again and again, it will give you different type of data only. So you can fit the random state actually. So yeah, now if you go to the variable explorer you will see the datas here, x and y. So in x we have two features, and in y we have two classes, 0 and 1. So using this data we are going to just demonstrate the logistic regression. Okay, So now what we are going to do is just we'll try to visualize the data. Okay, so then plt dot scatter. So we have two features x in x, so we'll plot for each and every. uh, so in x, take all the rows. In column, first we'll take 0 column. So the first column, so we are going to see the relationship actually, the two columns. So we'll take the next column, comma 1. So we have two columns, 0 and 1. Because it's a classification type of data, you will have two classes. So you can give in the hue equal to the class is 0 and 1, so you can give y. Okay, and then we'll show the plot plt dot show. Okay, what path collection object has no property hue. Okay, I think we'll use SNS. Okay, so what we can do is we can give color equal to y. So color will change. Okay, so now you can see this is now a classification data here. Sure, and again you will see a different data. This is because we have not set the random state. Okay, so the yellow colors are one class and the blue colors are one class. Okay, so now what we can do is just separate the data into, split the data into training and testing. Scale on dot model selection, import train test split. Okay, so now we need to give four parameters. Sorry, four, where it will return four values: x train, x test, y train, y test, y test. And we need to call the function, give the data x and y, and give the test size. Let's say 0.5, usually we use that. And then we set the random state now. So now let's don't set the random state, we'll set later. So uh, we are splitting the data set into training and testing. So in the variable explorer you can see now four variables are, four new variables you can see. So now we have splitted the data set, and then we need to uh, create the model, right? So after the processing steps we create the model. So the model is logit, and you need the class for logistic regression. So that can be found in the sklearn module. From sklearn dot, this also inside the linear model module. Okay, so what we use for linear regression, the same module, inside this module we have the logistic regression also. Here you can see. So we need to create the object for the class logistic regression, and then we'll fit the model into our data, training data. Okay, Now let's run these three lines. So we got the object fitted in our dummy data, the make classification data. Now what we need to do is we need to predict it, right? Predict the testing data. So log it dot predict x test. So now if you run this line, you will get the predicted results. So y pred. So here you can see this is the y pred. This is a predicted one, and this y test is an actual one. Okay, so this you can see. So the first is 0 and this also 0, so we have correctly predicted, and here 1 and here also 1 we have correctly predicted. Now we here in the second, the third class, you can see the predicted 0 but the actual is 1, so we have misclassified one data point. So other are classified correctly as I know. So here also the same case. So the it classifies as 0 but the actual class is 1. So like that we want to count how many datas are misclassified, right? How many are correctly classified, how many are misclassified. For if you have a linear regression, so if you have regression type of data, you will evaluate using some algorithms like R2 square or mean square error. So you will find the errors, right? How can you find the error of a classification type of data? So for that type we have another method called confusion metrics. So so confusion matrix uses a table of 2 by 2 matrix. It will tell you how many are correctly classified, how many are misclassified. Okay, so you can see here confusion matrix we have. A confusion matrix is a table that is often used to describe the performance of a classification model, okay, on a set of test data for which the true values are known. Okay, so we have the predicted and the actual value. If you have the predicted and the actual value, if we give the confusion matrix, it will create a table like this 2 by 2 matrix. So actual value is this one, positive and negative, and predicted value we have two, positive and negative. That means, for example, let's take this block. We have TP, right? True positive. True positive means the actual is one class, the class 1, and the prediction also class 1, that is a correct prediction, right? So now that is a true positive. This block is a correctly predicted one. And let's take the last block, TN, true negative. That means this actual, the class is 0, and the predicted also class 0. That means it's a correct prediction, right? So the true negative, the TN also a correct prediction. True positive and true negative, these two are correct predictions. So now let's see the FP, false positive. That means the actual is class 0 but our model predicted class 1. That means this incorrect prediction, that is false positive. Okay, and here also the same case, the false negative. That means actually is class 1 but our model predicted class 0, so that's the incorrect prediction. So false negative and false positive are incorrect predictions, and true negative and true positive are correct prediction. Okay, so how will you tell the accuracy? Okay, so it means we'll calculate the accuracy like in 100%, right? if you have 100%, or how can you tell that using the confusion matrix? We can uh, find the accuracy using the confusion matrix by like this. So you can have the equation like tp plus tn divided by tp plus false t no, fp plus tn plus fn. Okay, so that means correctly predicted divided by the whole the prediction. Okay, so this is the ratio of correctly classified inputs to the total number of inputs. That will be our the accuracy of our model. Okay, so now we are predicted, right? So now we are going to create a confusion matrix using the predicted result. Okay, so to create the confusion matrix we want the function. You can find in sklearn module matrix library, matrix module actually. Inside this module you will find confusion matrix function. Here it is. So it will return a matrix, let's say cm. Now we need to call the function confusion matrix, and it takes two parameters, y true and y pred. That means the actual is test and the predicted result is y pred. So now it will give you a matrix. So you can see cm here. Yeah, so you can see this is the matrix here, confusion matrix. So here in the blue color 51 and 49, these two are correctly predicted. That means 50, 90, 100 are correct predicted, and the 25 are incorrect predictions. Okay, so to find the accuracy we need to like ratio of total number of, sorry, correctly predicted, that is 100, and the total number of input is 125. Okay, so because you can see here the total number is 125, the test data. So this will be our accuracy. You can see 0. 0.8, right? How you can find the accuracy using the confusion matrix. And in one more thing I said before, uh, the logistic regression finds the result in 0 to 1, right? The range is between 0 to 1, but our prediction is like 0 and 1 only, because it is predicting as uh, probability only 0 to 1, but what it's doing inside, it's applying a threshold value 0. 0.5, uh, and then it is predicting as class 1 and class 0. So you can see that prediction also the probability, like we have a function predict probability. So we have predict proba, and here you need to give the test data. It will give you the probabilities. So you can see here, this is the probability it is giving. Okay, so after this only we what we are doing is we are taking the applying the threshold value, and then we are classifying 0 or 1. Okay, so now we have demonstrated it. uh, you can also visualize the result.
How do you interpret the result? Your predict the probability.
What?
In point number 19, you just predicted the probability, right? It's giving a
Yeah,
matrix. How do you interpret the result?
no, you can easily like simply you can say let's take as proba equal to the probabilities, and now we need the results, right? Results equal to If the probability is greater than, for example, greater than zero point 0.5, let's say, if that is greater than zero point 0.5, that will be a class 1. Okay, otherwise it will be a class 0. That's how you can apply the threshold value. Yes, I will run this. So now you can see the proba here. Wait, we need to apply it actually. Sorry, not proba, that's result actually. So true or false here. Okay, so first, of course it is giving two results, right?
Yeah, totally.
We need to take the maximum first, np dot argmax, because we have two features, right? That's why it is telling argmax, and axis is
Why are we doing the
uh,
max if two digits?
what.
Why are we taking the maximum?
So here, if we have two values, right?
Correct.
For two features we have two predictions. So we'll take the maximum one first, and if the maximum is greater than or equal to zero point 0.5, then we'll like classify with this maximum probability.
Fine.
Or one more way we have, like uh, we can just take the maximum only itself. Yeah, no, I think not argmax. If you take the argmax, we don't need this one actually. Yeah, now we can see 0 1 1 0 0.
Got it. So, do you know what is the threshold value right now with this logistic regression is applying?
What?
What is the
Thresh-
threshold value it is applying by default?
0.5. By default that is 0.5. In all the in the logistic regression, inside it is using 0.5 only. Usually we use that only. Here you can see that. Okay, so now what we can do is, so we have demonstrated using the dummy data. So now we'll use the data I have shown here now, the prostate cancer, right? So we'll use this data. Okay, so this is the data what I have shown in the Kaggle, the same data here. So now we'll use this data and going to predict whether the person has cancer or not. Okay, so for that, let me comment this all. We don't need this one. So we can remove this part, and then now we are going to read the data from the file, right, using the pandas read CSV file. Data sets slash prostate cancer. Okay, so now this is our data. So we have id column, that is unique, we can ignore that. And then here we have the diagnosis result, this is what we are going to predict. And we have radius, texture, perimeter. These columns we will going to use as independent variable x. Okay, so these have too many columns, right? So in logistic regression or some other algorithms, if you use, we have the concept called feature selection. The that method what we'll use when you have more columns, then what will have, what will happen, so the our algorithm will get slow in performance. So we'll, what we'll do, we'll select from the columns, we'll select for example 5 columns or 4 columns based on some criteria like correlation test, that has some correlation test. Based on the correlation test we'll select the columns, and that columns only we'll going to use for our building the model. Okay, so that method, for example the uh, correlation test, will give you the relationship between the variables. Okay, so using that you can find what columns are more related to the our result variable. If the, for example the area, let's say if the area is more correlated with diagnosis result, that means this column has more impact on the output, right? So we'll select this column like that. We'll test the correlation test and we'll see. Okay, so you can find the correlation like simply you can put data dot code. Okay, this the, it will create a table actually. So like this, we don't have the diagnosis result column. Why is because that's a categorical type of variable, so you cannot test the categorical type of variable in correlation. So what, first we need to convert the columns first, the categories diagnosis result m and b. So we'll import the sklearn. From the sklearn we'll import label encoder. We'll create that object first, and then we will apply it. Like for example data of the diagnosis result column. Okay, first let me check whether it has some nan values or not. Okay, all the columns has 0 nan values, so you can simply ignore the step. Okay, that's it. So after this, now if you put data dot core, we have this table, and in this table we have this column diagnosis result. So in this we have some results. In this result you want to pick some values. that has more correlated with this column diagnosis result. For example, let's take this column. It has 0. 0.6 correlated with diagnosis result. The column is perimeter, so we will select this column. So, and then for example 0. 0.5 is positively correlated, that compactness column. And this column, let's say 0. 0.3, it's negatively correlated, but that's an idea actually, so we can ignore that. Okay, no problem. We'll select another column, that is this one, 0.23. That's symmetry. Okay, so for this, if you uh, if you visualize as a table, you will not find the exact result. For example, this column in the middle, you cannot see the middle columns, right? It is ignoring the column. So we have the uh, plotting method called heat map. Using the sns.heatmap, here you can give the correlation data. It will create a heat map, data.core, and you need to give anode equal to true, and the minimum is -1, the maximum is 1. Actually, the correlation result will ranges between -1 to +1, that's why. And the center will be 0. So now in the plots, we'll see this plot, you can see. So now I will save this file and open it. So this is the plot. So here in the diagnosis result column, you can see some values here, right? So like 0.61, this correlated with perimeter column, and 0.5, it's correlated with the area, and this one column 0.51 is correlated with compactness. And okay, let's select these three columns only, like perimeter, area, compactness. So now we're going to use these three columns for independent variable x. So you can select the column data uh, dot lock all the rows, the columns that we are going to give, the selected columns. First one is perimeter, area, and compactness. Okay, and for y variable, the dependent variable is diagnosis result, right? Data dot data of diagnosis result. So this will give a data frame, so we need a numpy library, so we can put dot values. It will convert to numpy library, numpy array. Okay, now let's run these two columns, two rows, sorry. Now we'll get x and y. Okay, we have these three columns as x, and y is our predicted, going to predict this column. Now and then what we're going to do is we are going to split the data set into training and testing, this part. Okay, and then we'll build the model. Okay, first let's I will run these two lines. Okay, and then we'll make a model logistic regression fit into our X train and Y train training data, and then we'll predict this line. So now you can see the prediction result. So this is what the prediction is. So here we have, okay, so some points are misclassified, so we'll count the classified correctly and misclassified using the confusion matrix. Here, so you can see 11 plus 9, 20 results are correctly predicted. 2 plus 3, that are 5, are incorrect prediction. So 20 over 25 are correct predicted, so our accuracy will be 0.8. Okay, so now let's try to improve that using for example, I will set the random state equal to uh, stake 10. Actually, in the logistic regression we have a function called score. It will tell you what is the accuracy. The same thing what we are doing in using the confusion matrix, it will give you logistic dot score. So you need to give the test x test and y test. Okay, now let's run this. So that now it is 0.72. We'll improve using test size 0.76. Okay, you can see now our score will be 0.96. So the parameters is test size 0.3 and random state 0, then it is giving 0.96. Let's run again and again, you can see the same result because we have set the random state equal to 0. Okay, and that's for logistic regression. You have any doubts, you can ask now. Any doubts?
So one question. So we found the correlation between the data and we took three columns, right? So is there
Yeah,
any limit for that? You know how many you take and the best three, or
no,
how do you
that's your
manage?
choice actually. That's your choice. How many columns you want to select, that's your choice.
But obviously the results may vary, right? If I take only one, then the result might be something different from.
Yeah, so we can trial and error method we can use.
So this heat map giving you the best one with, if you see the red color and the slightly orange
Yeah.
color, based on that you went for it.
Yeah. So you can see here the best three are, you can see 0.61 and 0.56 and 0.51. So I took these three best columns. So all the other are like you can take this one also, 0 point minus 3 minus 0 0.3, or this one is 1, it's very less correlated. This one you can see 0.23. If you want to select on another, you can select this one or this one. So like that we'll first sort it out the columns based on the correlation, and we'll select the number of columns. Okay.
It doesn't matter whether it is negative or positive.
Yeah, because in the correlation we'll have ranges between -1 to +1. So if you have minus values, that will be negatively correlated. That means if our x variable, let's say the independent variable, is changing 1 unit, but the y variable is decreasing 1 unit, so that's a negatively correlated actually. Okay.
Understood.
Okay, any other doubts? Okay, uh, we'll end up this session. So we are bigdatahandson.com, our website, bigdatahandson.com. You can visit our website. Today is class 18, day 18. So all the other sessions are being uploaded in our YouTube channel. This is our YouTube channel, bigdatahandson.com. If you subscribe to our channel, you will get all the updates. So this is our YouTube channel. So until polynomial regression is been uploaded here, right? All the videos you can see here. If you have any doubts, you can message us in this number 978988844, and you can send email through support@vitatahanson.com. So let's meet tomorrow. Until then, bye.
Hey, I have a question.
Yeah.
I just started attending today because I just got message
Okay. Okay.
from yesterday from India. So my question is, if I continue to attend this, and also if I attend your meetings, your videos uploaded in YouTube, is that a good way to catch up all the tutorial, or what is the best way to approach and continue this training?
Yeah, because we are providing all the contents, right? Okay. So all the algorithms in AI we'll discuss in this series, because we have 50 sessions. So we'll start with actually we started with statistics and probability. So the three sessions are provided. I will show you the syllabus. Okay, wait, I will show you that. So we'll cover machine learning algorithms and deep learning, and then we'll cover reinforcement learning also. So we'll get all the ideas of AI. So what the AI is completely, you can find it in this series. Wait, I will show you the syllabus. So here you can see this 50-day session syllabus. So in the first 3 days, you can see here we
Mhm.
covered statistics, the descriptive statistics in inferential statistics, and then we covered the probabilities, conditional probabilities, and distributions. And then from day 4 to day 14, we covered Python completely. All the videos you
Okay.
can find it on our YouTube channel. I showed you.
Mm.
And now and then day 15 only we started machine learning. So now we are in day 18. Day 18 we are. So all the videos will upload in YouTube channel, okay? And then day 19 k neighbors, decision tree, random forest, naive bayes, support vector. So all the algorithms you can see here, right? We'll explain all the
Okay.
algorithms like for clustering, mean shift, hierarchical. We have db scan, k means, and association rule, a priori eclat. And then we'll use some dimensionality detection algorithms like pca, kernel pca, and linear discriminant. Okay, and then come after 929 we'll complete the machine learning. Okay, like model selection and boosting will cover. And from day 30 we start deep learning. Day 30 to day 40. Yeah, day
Okay.
40. Okay, so you can see the artificial neuron, ANN, CNN, RNN. And we'll cover two modules actually, two libraries using keras and tensorflow both. Okay,
Mm.
and then we'll cover autoencoders. These are some we'll see some projects actually. This one, autoencoders, generative adversarial networks, and this transfer learning. This is a topic we'll cover. Okay, and then object detection using the OpenCV library, you know that. And recommender system will cover. After this, these two are natural language processing, 41 and 42. And from 43 we cover reinforcement learning algorithms like UCB, and Thompson sampling, and the process of Markov, and Q learning, deep Q learning, A3C, and twin delay DTPG, and SASA and ARIMA. Okay, the last one is actually time series analysis, the ARIMA model. Okay, okay, this is what the
Okay.
syllabus is. You will get all the ideas actually in here.
So can I catch up if I start looking
Yeah,
at your YouTube videos up to
yeah, of course.
day 12?
Yeah.
Okay.
uh, until day 17, I think. Until day 17 we have uploaded the videos.
Upload. Okay.
Yeah. Okay, so we'll see
Okay. Thank you
tomorrow.
so much.
Okay, welcome.